for the grade 12 chemistry class of St. Peter's College, Colombo for Nigam branch. In this lesson, we are going to discuss about the P block group 16 elements. The elements are oxygen, sulfur, selenium, tellurium and polonium. First of all, I want to show you the content of our lesson. First, we are going to discuss about the group trends and properties of group 16 elements. Then, we talk about the hydrides of group 16 elements. After that, oxygen producing and about oxygen and about the allotropes of the oxygen. That means there are two allotropes in oxygen, O2 and O3. We call it for O3 ozone. After that, we will discuss about the sulfur and the allotropes of sulfur and oxygen containing compounds. Under that, we talk about water and hydrogen peroxide. Then we talk about the sulfur containing compounds. Under that, we talk about hydrogen sulfide and sulfur dioxide. At last, we will talk about the oxo acids of group 16. Under that topic, we are going to talk about the sulfuric acid, sulfurous acid and thiosulfuric acid. And first, I am going to focus on the group trends. Oxygen is the first element of the group 16 and as usual, oxygen shows the different characters than the other elements of the group 16. That means both oxygen and sulfur are non-metals and other elements in that group are metallic and non-metallic elements. So, if we consider about the metallic nature, when we go from top to bottom, the metallic nature we can see increases. Then there are some other group trends also. Only oxygen exists as a gas and all other elements are solid. Except oxygen, other elements can form oxidation state between +6 to -2 of the even number. The stability of +6 and -2 oxidation state decrease when we go down the group, but the stability of +4 oxidation state increases. Now we have to consider about the properties of the group 16 elements. If you take the electron configuration, all the elements shows 2s2, 2p4 electron configuration in the valence electron shell, and ionic radius you can see increase, covalent radius increase because when we go down new electron shells are added and the radius increases. and melting point you can see increase and electronegativity decrease, because when we go down, as I told you, the metallic nature increase and the electronegativity decrease. Then first electron gain you can see here increase, and then second electron gain enthalpy also decrease here. For the selenium, tellurium and polonium, there are no second electron gain enthalpies, because they normally tend to form the +4 oxidation state. Now we are moving to hydrides of the group 16. Hydrides of group 16 are very important, because the most important element in the earth is water, and water is also a hydride of group 16. That means water is a hydride of oxygen. So here we are going to compare the selected properties of group 16 hydrides. Here I have taken melting point, boiling point, bond length and bond angle, and compare the properties. So here there's a very significant incident. You can see the boiling point. If you take the first melting point, you can see melting point here decrease, and boiling point, there's a special thing in water. Water has higher boiling point, but other hydrides have very low boiling points. And bond length, water has smaller bond length than the other elements, but it has higher boiling point. Normally when boiling point increase, bond length increase, boiling point should be decreased, because when the bond length increase, easy to break the bond. So for other elements it is true here, higher bond lengths consist lower boiling point. But for water it is different, because water can form a special kind of bonds. We call them hydrogen bond. Due to that hydrogen bond, water has higher boiling point. Although it has lower bond length, it has higher boiling point. So this is a special thing we have to focus on. And there's another thing, bond angle. Here you can see, when we go from top to bottom in the group 16, the bond angle decrease. Why? Because when we go down, as I told you, the electron negativity decrease. And when electron negativity decrease, the repulsion of electron pairs of that atom decrease. When in higher electron negativity, the electrons tend to exert more repulsion. But in low electron negativity, electrons show low repulsion. So because of that, in here, the bond angle of oxygen is a higher number than the others because oxygen has the highest electron negativity. Then we have to talk about the oxygen. As you know, oxygen is also a very important gas to our life. If we talk about oxygen, oxygen has two electrons, O2 and O3. For O3 we call ozone. If we take oxygen, that means O2, oxygen is a colorless and odorless gas with slightly soluble in water. And ozone has unpleasant odor and also 111.5 bond N. Then how we produce oxygen? We can produce oxygen by decomposition of potassium chloride and hydrogen peroxide in the presence of manganese dioxide or and platinum. In first equation I have shown you that when we heat in potassium chloride in the presence of manganese dioxide or platinum, we can produce oxygen. And also when we heat hydrogen peroxide in the presence of manganese dioxide, we can produce oxygen according to these two equations. Then metals react with oxygen and produce metal oxides. Then if we take ozone, ozone is a powerful oxidizing agent, and ozone is used to disinfect agent as to the water. But normally we use chlorine as a disinfectant compound, but ozone does not produce any harmful byproducts. But sometimes chlorine produce harmful byproducts, but when we use ozone, it does not produce any harmful products in water disinfecting reactions. Okay, after oxygen, we have to talk about another group 16 element, that is sulfur. Sulfur exists in two forms, crystalline sulfur and amorphous sulfur. If we take the crystalline sulfur, it also exists in two electrodes. We call them rhombic sulfur and monoclinic. sulfur. And again, the amorphous form also exists in three types of allotropes: plastic, colloidal and milk sulfate. These are the allotropes of sulfur. And now we are going to consider about why sulfur exists like this allotropic forms. Sulfur forms single bonds with itself. Not like oxygen, sulfur forms single bonds, and it forms the crown shape structure, ring structure. It consists 8 number of sulfur atoms, and it is a cyclic zigzag arrangement. As I show you here, it is a cyclic zigzag arrangement. It consists 8 sulfur atoms, and we call this crown shape. In crystalline form, sulfur form this crown shape structure, and this crown shape structure can arrange in 2 different ways. By arranging these 2 different ways, it forms the 2 types of allotropes: rhombic and monoclinic allotropes. Because to form rhombic allotropes, it arranged rhombic crystals, and to form monoclinic allotrope, it arranged monoclinic crystals. Here I have shown you the crystals of rhombic sulfur and monoclinic sulfur. These are the 2 types of allotropes in crystalline form. As I told you, the crown shaped structure arranged in these 2 different ways. In rhombic sulfur, the crown shaped structure arranged in this way, and in monoclinic sulfur, the crown shaped structure arranged in this way. So these are the 2 types of allotropes in crystalline form of sulfur. And the most stable one is rhombic sulfur under 95 Celsius. But when we heat about 93 Celsius, this rhombic sulfur form the monoclinic sulfur. But under 95 Celsius, most stable allotrope of sulfur is rhombic sulfur. Then when we consider about the amorphous sulfur shows the elastic nature, and if we pour the melted sulfur into water, we can form the amorphous sulfur. But the amorphous sulfur is unstable. After a few minutes, that amorphous sulfur converts to crystalline form of sulfur. Now we are going to discuss about the oxygen containing compounds. In here we are focusing on water and hydrogen peroxide. This is the structures of the water and hydrogen peroxide. You can see here, in hydrogen peroxide there are two oxygen atoms and the structures are very different. First, let's take water. Water is very important because water is the most widely used solvent, and water self-ionized according to this equation, like this: H3O plus aqueous ion and OH minus aqueous ions. And also water is a amphiprotic molecule. That means it can act as an acid and also as a base. In here I have shown you that the amphoteric nature of water. When water reacts with HCl, it forms H3O plus aqueous ion and Cl minus aqueous ion, because in here it has accepted H plus ion. And when water reacts with ammonia, ammonia is a base. Here you can see the water has ability to release a proton. In here water release a proton and form NH4 plus ion and OH minus ion. Now let's take hydrogen peroxide. Hydrogen peroxide is a non-polar molecule. Water is a polar molecule, but hydrogen peroxide is a non-polar molecule. And the special thing is, hydrogen peroxide molecule contains two OH groups which do not lie in the same plane. Oh, it is not in a same plane. And you can see here the bond angles. And here HOO angle is 94.8 degrees. So you can compare the water and hydrogen peroxide, the differences. So bond angles are different. And if we take the two OH groups, the two OH groups are dihedral and it shows the 111.5 degree angle between two OH group. Here one OH group exists in this plane and the other one is in this plane, and the angle is 111.5 degrees. And due to the hydrogen bonding, hydrogen peroxide is a viscous liquid, and also it can act as an oxidizing as well as reducing agent. If we take the reducing reaction. In here, this is the half reaction of hydrogen peroxide reducing reaction. It forms water. And if we take the half reaction of oxidizing of hydrogen peroxide, it forms here oxygen. That means hydrogen peroxide shows the disproportionation reaction. Hydrogen peroxide can oxidize and reduce in the same time. In last reaction, you can see that in here hydrogen peroxide oxidized to oxygen and reduced to water. Now we are going to consider about the reactions of hydrogen peroxide. As an oxidizing agent, hydrogen peroxide react with iodine minus iron and form the I2 and water. And also it react with Fe2 plus ions and oxidize that Fe2 plus ion to Fe3 plus ion. Here hydrogen peroxide react as a oxidizing agent and as a reducing agent. In second reaction you can see that MnO4 minus ion oxidized to Mn2 plus ion, and also with dichromate ion reduced to chromate 3 plus ion. So these are the examples for the reactions of hydrogen peroxide as oxidizing agent and reducing agent. Now we are moving to sulfur containing compounds. Under that, first let's take hydrogen sulfide. Hydrogen sulfide is a colorless, toxic and acidic gas with unpleasant odor. Normally we know that odor is just like the odor of rotten eggs. So we can easily identify the hydrogen sulfide gas by the odor. And we can produce hydrogen sulfide by reacting metal sulfide with strong acids. And now we have to consider about the reactions of hydrogen sulfide. Hydrogen sulfide as acid react with bases. In here I have shown you how hydrogen sulfide gas react with sodium hydroxide base. With excess hydrogen sulfide, it forms these products, and with limited hydrogen sulfide, it forms these products. So you can compare the differences of the products when we use excess hydrogen sulfide and when we use limited hydrogen sulfide. And there are some other reactions we have to consider. Hydrogen sulfide reacts with metals as an acid. as an oxidizing agent. React with metals as an acid and form the hydrogen gas. And hydrogen sulfide also react as a reducing agent. There are three examples here. Hydrogen sulfide react as a reducing agent. So you can compare the products and you can check what are the oxidized elements and reduced elements in these reactions. Now another sulfur containing compounds is a sulfur dioxide. If you take sulfur dioxide is also a colorless gas and soluble in water. Sulfur dioxide also can act as an oxidizing agent and reducing agent. If you take the reactions of sulfur dioxide as an oxidizing agent, sulfur dioxide react with metal magnesium and it produces magnesium oxide and sulfur. And also with excess magnesium it produces magnesium oxide and magnesium sulfide. And another reaction as a reducing agent. When sulfur dioxide react as a reducing agent, we can give these three examples. Reaction with potassium permanganate, reaction with potassium dichromate and reaction with ferric chloride. These are the products that form as a reducing agent. Then at last we have to consider about the oxo acids of sulfur. There are three types of oxo acids: sulfuric acid, sulfurous acid and thiosulfuric acid. And first let's take sulfuric acid. This is the structure of the sulfuric acid. And sulfuric acid is a strong diprotic acid. That means it can release 2H plus ions. And if we take the reactions of sulfuric acid, first let's take how we form the sulfuric acid. Sulfur trioxide react with water to produce the sulfuric acid. In first reaction, it is shown here. Sulfur trioxide react with water and produce the sulfuric acid. And concentrated sulfuric acid act as an dehydrating agent. There are two examples: glucose and ethanol react with concentrated sulfuric acid and get dehydrated. Here carbon and to ethene, these are the products. So sulfuric acid can react as a dehydrating agent. if we take the reactions, concentrated hot sulfuric acid can act as a oxidizing agent with metals. There are two examples. Magnesium and copper are metals, react with sulfuric acid, and sulfuric acid react as an oxidizing agent. Here magnesium oxidized to magnesium sulfate and copper oxidized to copper sulfate. And second one, sulfuric acid react with non-metals like sulfur and carbon and produce here with sulfur, sulfur dioxide, and with carbon, carbon dioxide and sulfur dioxide. Dilute sulfuric acid act as an acid, and there are two examples for that. Sulfuric acid, dilute sulfuric acid react with sodium hydroxide and form the salt and water. And here with metal, it releases the hydrogen gas. So this is the normal metal acid reaction. And dilute sulfuric acid is a strong acid and can protonate to give 2 H plus ion to water. Here you can see it is a strong acid because with water it protonate and give 2 H plus ions. Now, if we take sulfurous acid, this is the structure of sulfurous acid. It contains only 3 oxygen atoms, but sulfuric acid contains 4 oxygen atoms. Sulfurous acid always contain small amount of sulfuric acid because there's a special thing happening here due to the air oxidation of that acid. Normally it contains small amount of sulfuric acid, and the sulfurous acid reacts with dissolved oxygen in water to produce sulfuric acid. In water, it also reacts with dissolved oxygen in the water and produce the sulfuric acid. So, the sulfurous acid is a weaker acid. I told you sulfuric acid is a strong acid, but sulfurous acid is a weaker acid than the sulfuric acid. At last, we have to consider about the thiosulfuric acid. This is the structure of the thiosulfuric acid. Thiosulfuric acid also a weak acid, and in aqueous solutions thiosulfuric acid can decompose to produce mixture of sulfur and sulfur containing products. Here you can see that. And thiosulfate ion can act as a reducing agent. thiosulfate ion can act as a reducing agent. Here you can see it reacts with iodine, that means with I2, and produce I minus ion. That means in here it has reacted as a reducing agent. So this is the structure of the thiosulfate ion. If we take these structures and consider about the oxidation states, the oxidation state of central sulfur atom is +4 and terminal sulfur ion 0 oxidation states. So you have to remember the different oxidation states of thiosulfuric acid. And these are the things of group 16 elements. In our next video, I hope to discuss the properties about the group 17 elements. Thank you.